I'm Anil Kumar, and in this video we will understand the very basic concept of linear quadratic systems. So when we will have linear quadratic system, then there will be at least one linear equation and one quadratic equation. When you combine them, then you'll always get a quadratic equation, right? So, and then the question will be how many solutions do you have? So what I've done here is that I've just taken a quadratic equation in general, and what we are exploring once again is trying to answer the same question, how many solutions do we have, right? And then we'll begin with some more questions on linear quadratic systems. Question here is, determine the values of k such that f of x equals to kx square minus 4x plus k has one root, two roots, or no real roots. So basically, to answer this question, we are going to analyze our discriminant b square minus 4ac, correct? Now for one root, what is the condition? For one root, the condition is that b square minus 4ac should be equal to 0. For two roots, it has to be positive, right? So b square minus 4ac should be greater than 0. And for no roots, that means no real roots, that has to be negative. That means if we have, in fact we will always have imaginary roots in that case, two roots, right? So a quadratic equation always gives you two roots. They could be real or imaginary. At times when we say one root, so both the roots have same value. That is what we mean by saying one root. Okay, so let's be very clear. There are two roots, right? Those two roots could be real or imaginary. If they are imaginary, then both will be imaginary. If they are real, then they could be two different roots or same double root, right? So that is how the case is. Now let's analyze this particular equation, which is f of x equals to kx square minus 4x plus k. How many roots do we have? Now here what you notice is that b is equals to minus 4, a is equals to k, and c is also equals to k, correct? So that is how the equation is. So b square minus 4ac what? B square minus 4ac will be minus 4 whole square minus 4 times a is k and c is also k, will be this. So we are basically trying to analyze 16 minus 4k square. Correct? So let us now analyze and figure out what is the condition on the value of k which will make these things happen, right? So we have to analyze 16 minus 4k square. So let's begin by equating it to 0 itself. Now it becomes simpler for us. So if I say 0, then I say that, well, in this case 16 should be equals to 4k square, or 4 should be equals to k square, or square root of 4. So whenever you do square root, you have to write plus and minus. Plus and minus 2 will give you the value of k, correct? So this is the answer. Plus and minus 2, this is 0. So that means the k could be equals to plus or minus 2 to give one root. So we have one solution. Now we have to decide, when are we going to have two roots or no real roots? Now whenever you get to this point, in that case you have two different approaches, right? So I will say first approach is graph. So you have two approaches in this case. First is graph, which I prefer. Now you have to graph 16 minus 4k square. When I say minus, it's a parabola which is opening downwards, correct? It's a parabola which opens downwards. So if I make a parabola opening downwards, then it is going to be kind of like this. Is it okay? Now you can clearly see from this parabola that here we have 16. If k is 0, 16, right? And these are my x-intercepts, which are minus 2 and plus 2. Now in between plus 2 and minus 2, it is positive, correct? In between plus 2 and minus 2, it is positive, this parabola value, this function. Do you understand this function? This function, the discriminant, I should say d. Okay, so I'm graphing discriminant d. It is positive. That means two roots. So when k is greater than minus 2 and is less than 2, we will have two roots. Do you get the idea? Because it is positive here. It's positive. Is that okay? But if k is between minus infinity to minus 2 and it is between 2 to infinity, we have no root since the value is negative, right? So in that case, we say if k is from, let us say, minus infinity to minus 2, union, I could say, right? And from 2 to infinity, these are different nomenclatures for the same thing, then we have no real roots. So that is one way of finding out. Finding with the help of a graph, correct? The other way is interval. So you could approach, these are the two methods, right? So interval really means that you need to draw your plane with the zeros. So you have two zeros. One zero is at minus 2 and the other zero is at plus 2. These are your zeros, right? These are these zeros. You have to take a test point on these intervals. So this interval is from minus infinity to minus 2. This is from minus 2 to 2, and that is from 2 to infinity. Now within these intervals, you have to consider test point, right? So let me write down interval here. These are my zeros which I wrote earlier. Then I am writing test points, right? So a good test point could be from minus infinity to minus 2 could be minus 3, 0 and 3, right? So now you substitute the test point in your functions, right? So if I substitute the test point in my function, which is 16 minus 4k square, correct? So these are the values of k. So if I substitute minus 3 here, then what do I get? Minus 3 square will be 9. 9 times 4 is 36. So what I get here is a negative value. Do you see that? If I substitute 0 here, so this is a negative value. If I substitute 0 here, I get 16, which is positive. So that is a positive value, which we get from the graph also. If I substitute 3 square is 9 times 4, 36, again a negative value. Do you see that? So these are the two negative values in the interval 2 to infinity and minus infinity to minus 2. So for these two intervals, we will not have any real root, correct? So that is another way of finding your result. So whenever you are analyzing a linear quadratic system, you will get across that kind of an equation at the end, and discriminant analysis helps you to figure out how many solutions you have. So when we say roots, it means same as solutions, right? So let me write down the word here, roots or solutions. Okay, so that means you are making it equal to 0, right? So how many will be decided by the discriminant d, which is b square minus 4ac. That is called discriminant. And these are the two methods to be applied, right? So we'll apply these methods over and over again, and I think with that you'll get enough practice to answer such questions and thereby solve linear quadratic systems. I hope that helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all.